Hello again. This talk is about linear equations and analyzing linear relationships, and then we'll get into linearizing, which is forcing a curve to be linear if it didn't start out that way. So, for starters, you probably remember from math class that we can write the equation for a straight line like this, where y and x are variables that can change from one moment to the next. M is a fixed number that we call either a multiplier or a coefficient or the slope. So y will always be like 5 times x or 9.81 times x. It'll be some number that's the same all the time. And in general, we have an extra number that we call b that could get added on at the end. But, good news, when we're doing these in physics, we often assume that b is 0, so we're only working with this version. So we have some relationship between two variables, x and y, where one of them is the other times a number. And there are actually a lot of physics laws, like our Fg equals mg is structured like this. F equals kx, Hooke's law for a spring, behaves like this. And there are quite a few others that will come up later on. So let me start with a dumb example just to give you an idea how this could work. Let's say you have two dogs, and one day you notice when there's two dogs in the room that you count and you find that there are 8 dog feet in that room. And you file that away in your mind, and then a third dog walks in and you notice that the number of feet has gone up to 12, and you think, intriguing. So you go and get 2 more dogs, bringing the total up to 5, and then you count the number of dog feet, and now it's up to 20. And you think, astounding. I wonder if there's some way I could use math to understand this better. Here's what you could do with that data to try to determine what's going on, or to see if, more to the point, to see if there's some kind of math formula hiding behind these numbers. We could make a graph where we have the number of dogs and the number of feet. And if we graph this, the number of dogs goes up to 5, so we'll need something like 0, 1, 2, 3, 4, 5. And the number of feet goes up to 20, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And if we graph these data that we found, we know that with 2 dogs, the number of feet is 8. And with 3 dogs, the number of feet goes up to 12. And with 5 dogs, the number of feet is 20. And we say that a relationship is linear if you can draw a straight line that pretty much hits all those points. So it looks like there is a linear relationship between the number of dogs and the number of feet, and that means we can write a formula that says the number of feet is some number m times the number of dogs. Amazing scientific breakthrough. And not only that, we can find this m number because it's a slope, and we learned how to calculate those in math. They told us that the slope of something is, you take the y-coordinates of 2 of the points and subtract them, and then you take the x-coordinates of those same 2 points and subtract them. So if we do that with these points, we would get something like 20 minus 8, those are the y-coordinates of 2 different points, over the x-coordinates of the same 2 points, 5 minus 2. I'm cleverly going big number minus small number so that the answers come out positive. That way I avoid dealing with negative signs. That's a nice thing you can do in some cases. 20 take away 8 is 12. 5 take away 2 is 3. 12 divided by 3 is 4. And so we have learned that the number of dog feet in a room equals 4 times the number of dogs. Now, you probably knew that 4 minutes ago because you've probably seen a dog before, but if you can do this with a dumb example like this, you can also do this with things like the spring constant for a spring or the gravitational field for Earth. This slope can be a very important physical constant. It could be something like the charge on an electron or the 9.81 that we use for Earth's gravity. Important stuff that's very useful once you've found it. So what we're going to do next is I'm going to go through some other examples and show you how to pull slopes out of them. And the first example is going to be another straight line, just so you can see this procedure again. And then we'll get into expressions that aren't even straight lines to begin with. And you'll see there's some math kung fu we can do to change them into a straight line, and then we can pull out a slope.